real quick. Now let's jam. Good morning to trigonometry. We're going to review factoring. Okay, just in case you do need to factor on the SAT.
Yeah, you definitely do. Oh, and while I was taking a little practice test, I went back and checked my answers because we squared the thing, and one of them was wrong. I was like, bam, Mr. Hunt, you have told me so.
Okay.
And I got the problem correct. So
Okay,
thank you.
good. But you got it wrong. No, you got it. All right, let's jam. Factoring, real quick here. This is pretty easy. You guys should know this. All yours, anybody? Two numbers multiplied to 6, add to -5. Yeah, all right. You guys can do that in your head. That's awesome. There's kind of different ways to do this. I think you guys learned it this way, right?
-3, not plus.
Minus, okay. Math teacher can do math. I think you guys did it like this right here, right? It's called the area method or the box method. Did you guys do that?
Yeah, the magic square.
The magic square, okay. That's easy enough. You guys talk to me. I've never used the magic square. You guys talk to me. How is this
Well,
done?
the magic square is kind of used for multiplication more often. It's better because so like you put the x negative.
So x square goes here, is that right? 6
Yeah,
goes here?
that's a different way to do it. We
When you,
mostly
like,
use
do a
boxes when
peanut
you are
thing,
multiplying.
that
We went
has
backwards
yeah.
for sure, but I like the X better.
Yeah.
I just don't remember how to do it.
It's like x squared and then 6.
The box is so stupid.
No, it's not.
It's literally the same thing.
We're going to have a debate in math class about which factoring method is good.
I agree with Grant. Diamond is better, but you can 100% do it with box. It's
I never
the exact same
understood the
thing.
It's
Okay.
you're just like working backwards with
And
the box.
diamond is this way, is that it? What is this guy
Yeah.
called?
Diamond method.
Diamond method, okay.
The better method.
You stupid X, okay. Out of curiosity, how many like this method? How many use that method?
Not like I use it, but not for this kind of a problem.
Sure, yeah. But the box, this guy, right?
No, I do.
Okay, how many like this one?
I use both.
Thank you.
Both, okay,
Yeah,
so you
yeah, for this
no
problem,
preference.
X is 110%.
I do box.
Okay.
Yeah, oh, so much better.
Yeah, I agree with you, Graham. I thought you were just dissing the box completely. and I
The
was
box
like, no.
overly complicates it.
Yeah, for this problem, it does.
Okay. Jamming, okay.
You're right.
We're gonna
Oh,
get somewhere.
wait,
We're
can
gonna
we
get
go
somewhere.
over how to use the diamond method
Yeah.
again?
Absolutely. So I like this one. I generally
Yeah.
use that one because it has a extension to it. So let me do one more just before we, this one would be good. That'd be easy one. That little 3 in front of x squared complicates things a bit, right? And what normally you guys are taught is something called guess and check. Hey, guess what? You're just gonna guess and check. And if it's an odd number, if it's a prime number, at least that's easy. At least that there's some easiness to it because you know that it has to be 3x times x to give you that one. So there's at least some ease. And then 8 would be 8 and 1, 2 and 4. So you have really 2 different choices here. What do you guys say? 2 and 4? I think it's going to be. What is the answer, anyways?
3x plus 4 and then times x plus 2, I think.
6 and 4 is 10, and we're good to go. Okay, sounds good. Xbox method, if you do it like this. Normally, you would put an 8 over here. But what we do is put a 24 over here first. So we multiply that 3 into the problem. We say 2 numbers multiplied to 24, add to 10. I think it's these 2. We're good. And then what we do is divide the 3 out afterwards. So when you do this, one of them is going to reduce or both of them will reduce. Doesn't matter here, but 6 over 3 will reduce down to 2.
What if neither?
They have to, then you did something wrong. So any denominators go out as multipliers to your x. Any numbers on top really become the numbers in the back. So technically 2 over 1, that little 1 is really the multiplier to the x in front. That's how you get the 2. And that little 2 is there.
Once you get it though, it's so much easier for SAT problems.
Say again, guys?
calculated stuff, it makes it so much
Do you
easier.
think you could do one without the 3x and just
If
like the x
you-
squared, like just no?
Just
thing
regular,
from-
just regular, yeah. Easy one, just do it, easy one, go. Something we know in our heads already. And do it this way. So the normal process, let's try it. Sorry, you guys are not familiar with this process. So the normal process is you take the number in the back, is 12. You take the number in the middle is down, and then what you do is, sorry, I gotta explain the process to you. Two numbers, yeah, two numbers multiply to 12, add to 7. So you start guessing in your head really quick. Boom, 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 and then you're like, oh yeah, that's it, 3 and 4.
Still guess and check.
That's wrong.
Still guess and check in your mind, yeah. Well, hold on, the area method, how is this not guess and check though? Really? Okay, George, explain, real quick, explain to me. How did
Well,
you,
I feel like it's just clear, like it just gives you more information, whereas the X is like you're literally just looking, like it doesn't feel as.
But I feel like you have to guess for the other one too. I like
You
the
have to
X
guess
better.
for it. You have to guess for both, and the X sets it up better. It
Yeah.
looks
Yeah.
better.
real quick here, somebody, George, explain to me how you would do this problem with this one. Like, where do things go?
So far.
You would, okay, yeah, it's kind of, so usually if you were starting from the two smaller equations, you would start with those on the outside, but since we're starting with a big equation, you would put the x squared in the top left
Mm-hmm,
box, and then 12 in the bottom right.
mm-hmm.
And then you put a little equal sign next to the top right box and put the 7x there.
Equal to, oh, right here, right, 7x,
Yeah.
like that, uh-huh.
And then you would bring, okay, the x out. So on top of the top left box, you put an x, and then to the left of the top left box, you put an x.
Uh-huh.
And then with the 12 and with the 7, you would have to, you would have to first figure out which numbers add to 7.
Yeah, so it's
Exactly,
this.
so it's still bad.
So you have, okay, so you
So
do,
the
you
two
do addition
diagonal
first,
boxes
though,
that are
right?
empty, add together to make the 7x.
To me, I just never really learned the cross as well, so it's always so much more confusing. And the box is just easier.
Mm-hmm, okay,
The cross is
It's
easy,
literally
the
more
box is like,
complicated.
is what I've
Yeah,
always.
like
No,
that,
it's
Georgia,
fine
you would,
line, though.
Sometimes one's clearer than the other.
I like the X one because you can do the cool over like the A value for the one and then get your like, I think you get your
From here.
And
multiplier
you put a
values
3 and a
easier.
4.
They
so
and I
like
are
plus
right
3
about
plus
Star Wars, we're right about that.
Yeah.
oh,
I
just
agree.
3x, right?
Yeah, 3x there.
We're generally right about most
Generally
things.
right.
And then you
If
can
Grant and I
bring
agree,
those
it's
up.
probably correct.
So this guy would be the 4, this guy would be the 3, and you have your,
The sequels are
Okay.
better.
Agreed.
gotcha, okay, that's cool.
Are you
No, don't
kidding
tell me
me?
you're on that
Or
team.
subhumans?
Early to argue.
You changed your opinion so that you can disagree with us. You are
I agree. We are subhumans, but we're correct subhumans.
Okay, are we good?
No, I really
Um,
like Attack of the Clones.
Out of curiosity here, before we really go crazy, how would you do this one with this box method here, the 3 in front?
Yeah, you just do the same thing except bring the 3 out.
Except more
And
complicated.
then you.
This is
you have
3x
to
squared?
know- Yeah. That for
Okay.
one of them is.
Okay, got 3x squared and 8, right?
So then you put
So
the
then you put the
3x.
10x?
at the top, and then when you're multiplying, yeah, the 3x, you would bring up,
3x here,
yeah, and then you would know when you're multiplying, because those like boxes line up, you would know that the 3x also comes into play, that's how you. Because it's like how you know that x and whatever lines up to, like they multiply to equal something, and 3x and something lines up to equal something, and then the 2 that you don't know line up to equal 8. So, but since you see it's 3x, you know that it's gonna not just be as simple as the x.
mm-hmm. So here you're gonna have, do you have a multiplier of 8 here? Is that how you do it? You got this and this?
You get even more.
Yeah.
What I
You
do,
have to guess
I
from 3
just-
directions.
I just come up with what multiplies to equal 8.
Mhm.
And then,
2 and 4, uh-huh.
yeah, 2 and 4, and
You
then
had the
since I see that it's
option.
10x, then I know that the 3x is gonna go with the 2, so then I put the 2 down there, and then I store up there. It's the same as the x.
Yeah, I just think it takes longer for me, not
Mhm.
necessarily just.
Okay, so yeah, there's a way to do that in there, in the
Yeah.
process of the box. Okay, cool. All right, I mean, did that answer your question?
Yes.
about how to do this guy with the extension. Awesome. Okay. Welcome to trigonometry. Okay. Thank you so much. I've never done this process before. I've always done that right there.
There's also the magic peanut.
Yeah,
I want to know
because it's
about
better.
that.
Ooh.
Yeah.
Oh, yeah.
You draw like a peanut around the 4x and the 2x. Like it's like a
4x.
circle, but just pinched in the middle.
I'm just gonna leave. you
Yeah.
guys to know.
And then that's how you know that those two are added together at the end.
Yeah.
Mhm,
So you know the
mhm.
ending of the-
Okay.
I forgot about the
Oh,
magic peanut.
Never
I feel like
forgot.
this was just the way that we learned it
Yeah.
in Algebra 1, like in 8th grade, so I feel like that's why.
Yeah, you
Some
just
of us
learned it.
still use it.
I kind of taught the X, but we rely more heavily on the box, I feel like.
Okay, yeah, it's just whatever when you were taught more so. Okay, cool, yeah. Thank you
We
so
weren't
much.
given the X as like a logic puzzle, like we weren't told what
Yeah.
to do with it. We just had an X and then two numbers, and they filled in a couple for us. I remember that worksheet. 'Cause I remember I was the first one who solved it, and I was so proud of myself.
Awesome. That's so cool. Okay,
X is still better.
yeah, it felt more like a puzzle than actually a
No, they
math
literally
problem.
didn't tell us how to do it. Like they filled in a couple for us and then
Uh-huh.
just gave us the numbers for the rest of them, and we just had to figure out how to fill it in ourselves.
Oh,
And that
gotcha.
was the only thing
Okay.
I did with it.
Uh-huh.
That way of solving it.
Algebra is a good
Awesome.
time.
And for some people, it would have been totally frustrating, right? Okay, Jammin, let's go with it. 6.3 is where we're at. Actually, I do have to ask any homework questions first off of
Yeah.
6.2.
Isn't it due on Friday?
Yeah,
It's
you-
gonna do on- it's gonna do on Friday, yeah. So if you want to take the extra time. Of course, if I said it was due on Friday, no one did it, right? Is that what happened?
Okay, I had a super cool day yesterday.
Yeah,
Not
yesterday
even
was
like- I spent like 6 hours on it. I just sat on my computer.
I still don't like my thesis statement, and I put so much.
I wrote my thesis and I was like, I need to do like 8 more hours of research before I can actually, yeah, okay, this is basically,
And then I was like, I can't tell if this is too much or too little, but here we go.
Yeah, I wrote a thesis
Can we
based
do
on
homework
some
questions
basic
on
knowledge that I
Friday?
already had. And now I'm gonna try to find the research. to
Yeah,
back it
go
up.
for it. One or two questions, whichever one you want.
I have 3. I have
I have so many
9,
sources and it-
21,
They don't all
and
connect very
29.
easily.
Oh, off 6.2. Okay, let's go for it here. Got 3 homework questions, and then we'll do some more on Friday, but 6.2 is due on Friday. Good. So number 9 is what we begin with. Sine 2 theta minus cosine.
For 6.2, I think I had a question on
Oh,
like
sure.
the last table, that it's not ours.
See if you can find it here.
Sorry, continue and I'll let you
No,
know. when I
okay,
figure it out.
perfect. Okay, I got a sine 2 theta. I have a cosine. So you can do one of 2 ways. If I'm thinking I see that I'm stuck with sine and cosine, I'm gonna move it over to the side and square both sides, right? I got that issue to deal with. I still have this issue of 2x. So I'm thinking to myself, sine 2 theta is, yeah, I know that. It's 2 sine theta cosine theta. If I substitute that, sorry, Hayden, 29, is that the
Yeah,
one?
I got it. It's
Okay, perfect. So let's do this here. We're gonna substitute that with the identity. Oh, set equal to 0, all right. That sounds familiar to me. How about I factor out a cosine theta out of it? Oh, not an equal sign, just factoring out cosine theta. And I got myself that right there. Are we good? Yes, I can bug people that don't have textbooks with them. I'll ask them for the trig values here. Cosine theta equals 0. Da, 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 da. Grant, when does that happen?
It happens on where x equals 0, so, good.
No,
enough.
he's doing it. He's
90 degrees and. Wait, you get power with me?
no, just kidding. Yes, it is true. 90 degrees and
180.
yes. Oh, not 180.
Oh,
Sorry.
you're wrong, 90.
Give him a chance. Give him a chance.
No.
Okay, you guys are harsh. Why am I? Oh, I'm in the last. Okay,
Why is this so?
90
Yes.
and 270. I go with 270.
Oh, yeah, because, yeah, right.
Yeah. No problem. No problem. Let's go with it here. Adding adding 1 to both sides, dividing by 2.
Where are we trying to find the degree?
Yes, it says 0 to 360. Sorry, I didn't share that with you here. Okay, boom. Matthias. Sine theta is equal to 1/2.
It's coming back, 30 degrees.
You're barely looking at the book.
There's another one.
Yeah, 150.
100, okay.
You just like whispered it.
Okay, boom.
You couldn't hear me over the people trying to discredit my discovery.
You discovered it now.
We successfully.
Technically you did. You discovered it in the book, but it's still.
Yes.
To him today, it was a discovery. Okay, boom. Are we good there for those 4? And just making sure those are the answers. Hello. Okay. 20.
Great, you're the only answers. Wait, what did the last one say?
30 degrees.
It's like 30, but the 3 looks like a 7.
Yeah,
Ah.
the 70?
No, look, you can see the little wiggly thing,
Yeah, I got the wiggly thing in there.
and so it looks like a.
It looks like
It was 2 wiggly things.
You can tell it's a 3. Looks like an invertebrate 7. Yeah, like after Bane got through with it.
They're making fun of my numbers. That's what it is.
I'm sorry.
It's okay. I determine their grade. It's
I
okay.
mean, that's
Yeah, why are they laughing? Grant, you laughed, but it's true.
Jeez. Yeah, I was horrible.
Boom.
Negative 10.
Explain to your parents that you're not failing clear because you don't understand.
Or both.
That one day in trig class.
Yeah.
Okay, let's see. This is now radian measurement from 0 to 2 pi. It's the same as degree measurement here. Cotangent. I'm thinking I'm going to change this to Grace. Cotangent.
Whoa.
Minus cosecant that graph. Perfect. Yep. Even though it's say 1 over sine, but it's sine of x, right? We always have to include that little variable inside there at the end. Okay, I'm good there. Let's see. Let's work our way through this here. I think I need common denominators at least first. So let me do this here. I'm going to put a little 1 underneath here. I'm going to multiply this guy by sine of x on top and sine of x on the bottom. At least that'll give me common denominators. It gives me 2 sine squared x over sine. Plus, I got this here. Minus this. I'm getting closer. Oh, and then let's write it all underneath one big giant sine of x. Boom. And
Wait.
oh yeah, can't factor because one is a sine squared, the other one's cosine. That's no fun.
Multiply both sides by sine x.
Okay, let's at least do that. Let's multiply both sides by sine of x. The only thing is we had to declare something out here. What do we declare?
Sine of x is not equal
Yeah, the whatever. It's called 0, but whatever. Okay, sine of x on this side, sine of x on that side. So that's cool. Got rid of that. Then sine times 0 is still 0. So 2 sine squared x plus cosine x minus 1 equals 0. Okay. that correct? Georgia, any thoughts?
Can you do the quadratic? Is that still not one?
Yeah, yeah, it's the different, if this was sine of X, that would be awesome, but it's not. Bummer. Something about Pythagorean theorem though,
Yeah,
maybe
I was
might
gonna
work.
say, can't you change the sine squared x to 1 minus the sine squared x?
Yes, awesome. I think we can do that here, right? Because if Pythagorean theorem works, if that is true, then we also know that this is true. That's the one that we want. So let's bring this down. How about 1 minus cosine squared x?
Also, isn't the whole point of this that you answer our questions, not give us more questions? Right?
Do,
It's
do, do, do,
just-
do,
it's
do.
just socialized homework.
I think so, but it's gonna happen this way anyways.
We're gonna keep going, okay.
We just repossessed the needs of homework. That's all this means.
Plus 1. Let's see,
You know, what we
before I
want
do
actually
stuff,
just tell us the answer without doing any of the work.
5. I'm gonna multiply through by -1 because I don't like to factor anything else with my leading coefficient being negative. So I'm gonna go like this. Eventually till you get to the end. Adrian, what should we do?
Solving for it.
Say again?
Excellent question.
Excellent, yes.
I bet that you can do the x.
Hey, all right.
Subtle plug.
Uh-huh.
I despise you.
Wait, so for the X, you would
I
do,
already despise
the
myself.
top is -1 and the bottom is -1?
Oh, no.
For
Say
the
it
X
again.
thing? Is the top -1?
Yeah, sure,
and
let's
the
go with it
bottom
here.
-1?
So if we go like this, turn it back into an algebra problem if you need to.
Oh, yeah. you have to do the
Right.
two.
So it's gonna be this times this gets you -2. Ooh, -1. Oh man, that's gonna be a fun one. Something I did not mention.
Well, it's 2 and 1. Well, sorry, no, 2 and negative, wait, -2 and 1. There we go.
-2 and +1. Divide through by 2.
See, that's what I don't remember doing in the past.
I don't think we
Yeah,
ever
we
did
just
that.
did that.
So that's a whole number. That's nice because that's just going to be cosine, or actually let's do it the algebra way. This will be x minus 1 because that's a whole number. Or you can think of it as a fraction where the denominator goes in front of x, numerator goes behind the x. Here, same thing here. The 2 goes in front of the x. The numerator goes in back. All right, translating it into trig function mode here, that x is my cosine, so how about cosine x minus 1 to cosine x plus 1. Phew, almost at the end. How about cosine x equals to 1, and then we have, can we do this in our head, subtract 1 divided by 2?
Maybe 1/2.
Maybe 1/2, boom. And who's up? Nicholas, all yours. Cosine x equals 1 when? In radian measurement.
Is it the 184?
This would be -1 over here. The other way. I think it's gonna be on this side of that. If that's -1, it's gonna be right over here. We'll go with 0.
Yeah.
Perfecto. Got 0 here. Then I need cosine x be -1/2 Amaya. All yours.
I think that's for 2π/3 and 4π/3.
I go with that here. Whenever I think of these guys here, I always think of this guy as being away from the x-axis. So this is going to be the largest value. So this is √3/2. That's √2/2. This has to be the 1/2 then. Boom, and that's going to be 2π/3. Same thing happens on this side. This is -√3/2, -2/2, -1/2 would be down here. 4 pi
Can you
over
explain
3.
that one more time?
Sure, sure. Let's do it on this one. Let's do a big one. So,
What did you write on the last one?
2 pi over 3 and 4 pi over 3. All right, unit circle. Let's go for it. The easiest way to do it is if you think of trig functions here, they go in this range. They go 0, then they go to 1/2, then they go √2/2, √3/2, and then eventually a 1. To remember them a little bit easier, you can even do this here. Square root of 0/2, square root of 1/2, square root of 2/2, square root of 3/2, and is that same thing as square root of 4/2? What? That's crazy. They're just square roots going up. Okay, but this is your list that you have to go through. And so if you're looking at let's do the y values first, because the y values are easier. If you're looking at a unit circle, the y values are going to go up. And so from here to here, it's going to go from 0 to 1. So as you travel around the unit circle, the y values are going to go 0. This has to be a 1/2 for the y values. √2/2 is always going to be the 45, so that's an easy one. So then √3/2, and then you get to 1. So y values, let's start off with this one here, 1/2, square root of 2/2, square root of 3/2, and eventually you get yourself to 1. And they go back down. Good. That's the easy one, the y values. The x values, you think of the distance from here out. And so in this case, you're going to say, okay, that's going to start off with 1. Oh, sorry. I should have done this one here. Right, so the x values are going to go down as the angle gets closer and closer, as your point gets closer and closer to the y-axis. So in my mind, I always think about if I'm going to raise 30 degrees, that means this is the furthest away from the y-axis. This is always going to be √2/2. And so this one, notice the length here compared to the length here back to the y-axis. So this guy would have to be the shorter one. And it's the 60-degree angle here. Or pi over 3. Okay, does that help? Does that make sense, guys? Just to memorize it here, and that will be 0. Okay. And I think I'm done with this one here. So 0 is from this guy. And I got 2
But
pi
can't it
over
not
3.
be zero?
Perfect. So then let's go back here. The only thing that we have to think about is when that little piece takes place. So sine of x equals 0. This one was cosine of x equals 1. Is that right? And is that true? Is that the same thing? I think so. Okay. Look in the back of the book just to make sure. Can we look with Bob? Bob is a good friend. Every once in a while, he makes a mistake.
Actually, not on this one because it's only like.
Big mistake.
Yeah, that's what I thought.
That's
I was
what I
like,
was
big orange
wondering.
binder, what is that?
One big mistake.
We're good? So at this point, yes, we do have to get rid of this little 0. It does not belong there. It can't be, because if we were to plug it back to the original equation, we get undefined terms. Good catch.
So why do you plug it back into that equation when we didn't square anything?
You don't have to plug it on this one. But if you did, yeah, if you did, it would not work. 0 plugged in would cause this guy here to be undefined.
Yeah.
And at that point, 0 does not work.
So do you just have to like know that and check all your answers anyway, even though you're not squaring them?
If you have not squared both sides, you do not need to check your answers. It is only when you square it that you have to check your answers.
Because sometimes when you square it, you will get answers that do not work.
Right.
But otherwise, if you do all the work correctly, the answers that you get will always be right.
But we did all the work corrector and the answers were not right.
Oh, because it's 0 and you already said that
Sine
sine of x cannot, because we
Zero.
multiplied the 0 by the sine of x to get rid of it on
Mhm.
that.
So that's how you would know?
Yeah, it's this
Okay.
little step right here. And if you want to, you can even list a few answers here, right? So you say to yourself, okay, when is that true? When sine equals 0, it's at 0, it's at pi, it's at 2 pi, ... So if I get any one of those answers, I'm gonna discard them. Good there. Yeah, so in this one, whenever you have fractions you're multiplying through, you already know what it can't be. If you square both sides, then you don't know what it can be. So therefore you have to check. Okay, 6.2, 29. Okay, nice. It is set equal to 0. We're going from 0 to 360. So degree measurements here. I don't like theta over 2. That's one thing that I don't like. I can change it, maybe, possibly. We'll see. Wouldn't that be? What is that?
Plus or minus the square root.
Oh, gotcha. Okay. Is the square root like this? Right? 1 minus cosine. Right? And the 2's inside the square root? Okay. Now I guess that solves a little problem here. So if I change it to this, it gets more complicated. I'm going to have to do it anyways. So let's do this here. At this point, I'm stuck. So I'm going to move the cosine over. That's cool. I at least got those. Now I'm going to plug this in. So plus or minus the square root of 1 minus cosine theta over 2 is equal to cosine theta. Voila.
Wait, but why would you want to move the cosine over if it's already 0?
Question comes up. Why move the cosine over? Because if it's equal to 0, like the first one, like number 9, right? Number 9, we were able to factor something out. In that case, you don't need to move it over. You have two things that are multiplying to 0. Now you could separate them. This one, you can't separate them because of the trig function is stuck. If it was a different identity and it had cosine theta inside it, then yes, it would have worked just fine. Okay, good there. Answer the question. Let's jam. I'm going to do this here. That's the only way to get rid of that square root, first of all. And so that goes away, that goes away. And I'm left with something that looks like this now. Cool. Now I can think let's see, multiply by 2. So 2 cosine squared theta. I haven't bothered the rest of the room yet. So Haley, what should we do now? I give you a hint, it has a cosine theta, so it has a cosine squared inside it, and also has a cosine. So it has a square term and it has a single term. Perfect. Move everything over to the other side. Boom. So I'm going to add cosine to both sides. I'm going to subtract 1 from both sides. Perfecto. And we are here again. This one, if you did it by the guess and check method, just like this, you know this guy is a 2, it's a prime number. So the only way you can get a 2 cosine squared theta is 2 cosine times cosine. And then we get to figure out at the end what multiplies to -1 so that in the middle I get a positive cosine. After doing these a few times, I think a positive 1 here works out nicely because if you multiply these two out, that gets you 2 cosine. minus a cosine gets you that cosine theta in the middle. Are we good there? All right, 2 cosine minus 1, cosine plus 1. Split them off, set both of them equal to 0, or set each of them equal to 0. Both or each, I'm not sure. Both set equal to 0. Uh-huh. It's interchangeable in that way, huh? Both set equal to 0, each of them set equal to 0.
I mean, I think that if you want to be extra clear, each would be better, but I think everybody knows what you're saying.
Mhm.
And then
Let's see, 1/2 and cosine theta is equal to -1. Boom. Rylan, I haven't bugged you yet. Okay, cosine theta is equal to 1/2, especially after the awesome unit circled explanation. Oh, in degree mode, yes, we're in degree mode. Cosine theta is 1/2, it's the x value, right? Yeah, it seems like 30 degrees and 60 degrees. That's the only one that you can keep mixed up on. Is that right? 45, pretty simple. Quadrantal angle is pretty simple here. So the distance away from the y-axis, that's the long distance. That has to be the √3/2. This is the short distance. That has to be the 1/2. So boom. All right, I'm going to go 60 degrees. Yeah.
Yeah.
60 degrees here, and then also we got to find the other one here. So that's a positive. We have to go all the way down here. So 60 degrees away from 360. 300 is perfect. Awesome. Okay, boom. And Corinna, all yours. Make this perfect. And did we square both sides anytime? Yes. Oh, bummer. Okay. Row 1, can you guys check 60 degrees? Row 2, can you guys check 300 degrees? Row 3, 180, and row 4, 180.
me too.
Row. Row 1.
I am designating you row 1. Row 1.
No, that's because you guys were just saying bro back and forth. So I was like, that's fine.
Row 1.
Sine of 60 degrees divided by 2 minus cosine of 60 degrees, that gives you 0. Yes or no? Sine of 300 degrees divided by 2 minus cosine
This is easy.
of 300 degrees gives you 0. And sine of 180 degrees divided by 2 minus
0.
Bro 1. What'd you guys get?
This is how it works.
It works, okay.
Sign of my title.
Row 2.
Super genius. Row 1.
I'm not done, so.
Not done, okay. Just waiting.
Oh.
Let's see, sine of 180, 150 degrees. Cosine of 300 degrees. I don't know. Adrian, what is sine of 150? 1/2. And then cosine of 300.
It's the stinky negative square root 3/2. Oh wait, cosine, sorry, no, that's
Cosine.
also just 1/2.
1/2. Okay, perfect. Boom. Okay, 300 works. We're good? Bro 3 and 4?
No, doesn't work.
Does not work. Okay. Crash that. Okay, so 60 degrees, 300 degrees only. You got 2 different answers only. Boom. Okay, we almost got to 6.3 today. So we'll start with any other homework questions on Friday. Otherwise, we'll do 6.3. I'm gonna only take 2 homework questions. How about that? It's a joke. All right, guys, have a good rest of the day.
Yeah, the same ones again.
I was like, we have a sleeping at lunch, so I won't be.
Bye-bye.